Okay, this next one we're looking at trying to find the volume of the region bound by the parabola y equals x squared. So let's sketch that. And the line y equals 2x. So that's going to be a line with a slope like this. So we're taking this little region in here and we're rotating it about the y-axis. Okay, so when we rotate about the y-axis, we're going to get, let's see, how do I draw this? I don't draw this very well, I guess is the answer, but one particular slice is going to be a washer here, we see. Okay, so we know it's again going to be washers, and we know it's going to be in terms of y. Make sure you know why those are both true, right? Washers because our region is not right up against our axis of rotation, and in terms of y because we're rotating about a vertical axis. I'm going to erase some of this. Oh, that was a bad idea. I guess we're not going to erase part of that. Okay. So let's start setting this thing up. So we know that we're going to have our volume is going to be pi, our appropriate bounds, we'll have to find those, and we're going to have the outer radius in terms of y squared minus the inner radius in terms of y squared, dy. Again, when I'm looking for your work here, I'm looking for everything in terms of y, that you write the dy, that you write an expression for your capital R of y, and you write an expression for your little r of y, and that all of these pieces are there. Okay, so it doesn't really matter where we start. I guess I'm going to start with the outer radius. So let's think about what's the outer radius is the distance from the axis of rotation all the way out to this edge here. So that's going to be to the parabola, but we have to be working in terms of y. So remember that y equals x squared means that x is plus or minus the square root of y. So this part is the positive square root of y. This part would be the negative square root of y. It doesn't really matter which way we go, but it's more natural to actually go to the region. So this is the region we're starting with, right? And then we rotate it. So I'm going to go, the distance from the y-axis to this curve is the square root of y. So my outer radius is the square root of y. And then that's going to get squared. And then we have the inner radius is the distance from the axis of rotation to the inside where the hole is. So that's the distance to the line, y equals 2x. But again, we have to work in terms of y. So instead of y equals 2x, we divide both sides by 2, and we get x equals y over 2. So my inner radius is going to be y over 2, and we're going to square that. Actually, I guess I want that in black. Let's erase that. Okay. All right, so now we need our bounds in terms of y. So we could solve either. So let me show you both ways. So we could set x squared equal to 2x, and this would give me my bounds in terms of x. So I factor this by factoring out a GCF, x minus 2. So again, zero product property tells me either x is 0 or x equals positive 2. So this tells me that this point is 0 comma something, and this is the point 2 comma something. But I'm more interested in that something, the y value. So I could take these values, put them into either one of these equations. 0 squared is 0, or 2 times 0 is 0. So either way, that's 0. 2 squared is 4, or 2 times 2 is 4. So I get my y value of 4. So I can do this directly. I could do this through x and get y sort of in a roundabout way, and I get my bounds are from 0 to 4. Just so you know that if you wanted to, instead, we already had our equation in terms of y. We could have set these two equations equal to each other. So we'd have the square root of y equals y over 2. Solving radical equations, the first step is to square both sides. So we get y equals y squared over 4. I'm going to go ahead and actually just multiply both sides of the equation by 4 to get rid of that denominator. So now I've got just y squared over here, and I could subtract the 4y over to the other side since it's quadratic. And then, again, factor out the greatest common factor. And so zero product property would tell me my two y values are 0 and 4. So I could have gotten those y values directly. And it doesn't matter which way you do it. It's whatever you like best. So here is our integral. That's the setup. That's what I'd be looking for. If you're interested in the answer, I believe we get 8 pi over 3. And so that's the volume of that solid.